Welcome to Data and Marketing Nation, the podcast that keeps busy professionals like you up to date on all things connecting data and marketing. My name is Dimitri Visnadi, and I'll be talking with experts to help uncover innovations, ideas, and insights. So let's go! Hello everybody and welcome to another episode. Today I'm joined by Simon Stiebellehner, very impressive candidate in the world of data science and especially nowadays also an influencer on LinkedIn with at least 8,000 followers. Welcome, Simon.
Thanks, Dimitri, for that introduction and happy to be here in your podcast.
Simon, could you give me a quick introduction about your journey? I mean, how did you come to the world of data science, your academic background and your professional background?
Yeah, thanks for asking. So my journey in data science actually started back in my bachelor's studies, which I did at the Vienna University of Economics and Business. And there I was studying information systems, so kind of a mix between business and computer science, which I think is actually, looking back, quite an interesting place to start a data science journey, because also data science often sits at that intersection. During my bachelor's, I already was quite involved with different kinds of statistical analysis, a lot of empirical social research, tons of classic regressions, hypothesis testing and all that stuff. A lot of that in R as well. This is how I kind of, without knowing it, slided into that field of data science. Back then that name, well, I think, at least to me, didn't really exist yet. After my bachelor's, I took a gap year and worked, among other things, also for Microsoft in Germany. I also this kept coming back to me. I was working kind of at the intersection between marketing automation and marketing analytics. So obviously, already telling by the name, there is analytics involved. And back then I thought when we did some lead scoring and based on that launching different campaigns and targeting different campaigns, I was already quite intrigued by how this lead scoring is actually done. What are the algorithms behind it? How does the software actually recommend you who to send what kind of newsletter, at a really large scale? So that is then where I learned, where I could apply some of the stuff that I did in my bachelor's previously, but also, it really gave me that spark so that I knew my next step in my master's, I really want to focus on that field. And that's actually how I got to know this wonderful podcast host, Dimitri. I did my master's at University College London together with Dimitri, actually. There, we really went deep into the field, having world-class professors, world-class lecturers, and also quite a demanding program, I would say. But that really, I remember our program director telling us in one of the first days, after that year, you're going to feel like you're going to have superpowers. You don't realize it during that 1 year journey. You're really drilled and knowledge is pumped into your brain. So I must say, again, in hindsight, that year was super intense, but also it really set you up for success in that field, I would say. Yeah. But back then, actually, it was still a lot more about algorithms, really coding neural nets from scratch, calculating them by hand, doing back propagation by hand, all these things. But so that actually then really put my foot to the field of data science.
Interesting. I mean, such a journey. We all started off with some, question that we tried to answer at some point. As you said, how do the things work? What are the algorithms behind it? And then you just go on the journey. You want to learn more. You do more, exercises at work, online classes on Coursera. And at the end, maybe you even go to university.
Yeah.
And nowadays, after you got those super human powers, basically, after our masters, which I felt the same. What then? What happened then?
Yeah, so actually, I was pretty hyped about staying in research, working on all that cutting edge and bleeding edge stuff you learned during your masters. DeepMind was giving courses at UCL, and you had this super inspiring bleeding edge research field there. So at least for me and also many of my colleagues, it was like, yeah, I really want to do a PhD because I really want to continue with that. So that's actually what I did straight after I handed in my master thesis, and a week later I started as a research and teaching associate in the field of computational advertising, at Vienna University of Economics and Business. So actually going back to where it all started, I met some really, really nice colleagues there, some really nice PhD colleagues, was super warmly welcomed also by by the department. But eventually, after some time, on the one hand, you get to work on all that bleeding edge stuff. But on the other hand, actually, you working on all that bleeding edge stuff is maybe 5% what you really spend your time on. The rest, at least for my position back then, really went into teaching on the one hand, which was a nice part, but also a lot of administrative effort. So eventually, you actually only end up spending a fraction of what you thought, what you had in mind on that bleeding edge research. So after some time, I was like, that's really, going a bit too slow for me. Impatient person, I really want to move stuff forward, which is not something that goes well with doing a PhD. In hindsight, in hindsight, you're always smarter. So actually, after a couple of months, I was like, oh no, I think there are some quite interesting problems to solve as well in industry. So I joined this wonderful company called Kraftwerks, also in Vienna, consulting, rather small consulting company, having I think nowadays around 30 employees, really focused on developing big data architectures, big data infrastructure, and also on top of that, usually data science use cases, especially for industry, meaning for large manufacturing companies, automotive companies. That was actually really that's what I wanted to do when I handed in my master thesis. That really floated my boat. Super interesting use cases, very nice company culture.
You had exposure to also different types of projects.
Exactly. So that, I think, at least for me at that point early in my career was really a sweet spot, being in a smaller consulting firm that still has super interesting projects, actually, because that allows you to see a lot, right? A project maybe took you 3 months, 4 months. So you could really see a lot of different companies, how they work, what problems they're facing in a very short time span. And then when being in a small company, also you can actually drive a lot of things forwards and you really get a large chunk of responsibility from day one. And that was really something that I found a really good start into my professional career.
Do you think that applies for every, let's say, an analyst or data scientist? Because you also need to have some knowledge when you come in, because if it's a small company, you probably don't have a lot of resources that train and teach you. Mm-hmm. And again, you also need this drive. Drive comes from once you already know what's out there, what's possible. And if you're, let's say, a junior, again, you don't really know what's out there. You still want to learn.
Absolutely. So I think that's a ask, especially when you're new to your job, or when you really leave academia, when you got your bachelor's, your master's, your PhD, and whatever. I think one of the most important questions you should ask yourself is, do I actually want to work in a more like a startup-y company, or in a large corporate, or all the shades of grades in between? But talking about these two poles kind of is super important, and thinking about that, because that has a lot of implications around what you will be responsible for, also the support you will get, the freedom you will have. And these are very important aspects that really define your happiness in your job, but also the success in your job. So you need to understand yourself. What is the environment I want to be in, and that I can strive in? And I think classic, like in a small startup environment, you will get a lot of responsibility fairly fast. You will have a lot of freedom. Also, do not expect a lot of support. Probably there is a good chance that there is not a person that is more senior to you in your field. So that means do not expect, getting like a lot of mentorship. Do not expect having like streamlined training programs. Most likely you're not going to get that. If you want that, you should really look more for corporate companies, for larger companies. On the other hand, if you're really a self-starter and I feel like, I want to figure that out by myself, and that can be quite inefficient sometimes. Definitely, you're more on the startup.
And then after you had this exposure of consulting and, let's say, data science in consulting, where do you go then?
Yeah, so at my last year at Kraftwerks, I took over the head of AI position there. So basically, then I was leading this team of 5-6 data scientists. Next to that, we were also developing a machine learning deployment and serving platform. So essentially, in a nutshell, a platform that allows you to drag and drop your model into a web UI, and it's going to deploy, serve, and monitor your model there. That's one of the things that we started developing in my last year there. Now I think it's actually released. It's called Navio.ai. And that was super important then for my next step, because that is actually when I put my toes a bit into the field of actual what nowadays you call machine learning operations, MLOps, really about how do you streamline and generalize the deployment, serving, and monitoring of these models, and how you actually make it easy to your users. So I got to know that field, and that really again sparked big interest in me. So I knew my next step should be a lot more on the engineering side. At Kraftwerks, as the data scientist, you already were end-to-end responsible for what you develop. So nowadays, you would call that a machine learning engineer. Back then, the term didn't really exist. But, well, my development there really told me next step should be really more on the engineering end. That's where my interest lies. That's where I want to develop further. So I moved to the Netherlands from Austria and joined bol.com, which is the largest e-commerce retailer in the Netherlands. People are always like, oh, why isn't that Amazon? Well, the Netherlands are special in that regard. Amazon actually has only entered the Dutch market, I think now 2 years ago. But before, there was bol.com for like 20 years. So it's big. Nowadays, it's also still bigger than Amazon. There I joined as a so-called expert machine learning engineer, meaning essentially kind of a staff engineer for machine learning engineering. I was embedded in the customer service domain. You know, customer service typically sounds a bit boring when you hear the name. Actually, it's not at all, because you get to deal with all that, with all the fancy data that customers give you in their interactions, meaning when they give you a call, and when they send you an email complaining about something, when they chat to you via the chat, whatever. So that's all the data that lands in this customer service domain. So that obviously gives you as a data scientist or data analyst or machine learning engineer, it gives you quite a nice playing ground. So there I was embedded in a team where our goal was to understand the customer. All the interactions that come in from customers, we would try to not understand it in terms of a chatbot, meaning what does the customer want and then give a reply. That was actually another team. But what our goal was to imagine it like you want to tag every problem or question that a customer has. You want to put multiple tags on it to understand, okay, what is that about? And based on that, also think about, okay, where does this problem actually originate? That's an important task. Why? Because as customer service, you always encounter problems. People call you because they have a problem. But you, most likely, as customer service, did not create that problem. Problems are created upstream. They are created in logistics. They are created in procurement, somewhere else. And if you do not manage to programmatically understand and funnel these problems that hit your plate in customer service back to the department where they originate, you can't really fix them. You're always one step behind, and you're just trying to cure and make the customer happy again. Ideally, they wouldn't even call you.
Wow. First of all, I have to quickly say that having you on the podcast is already fun because you're asking yourself the questions. So I think that's always the best part. But apart from that, so much, let's say, can we call that already marketing data? I mean, it's connected to the user on one side. It's collecting information about, and it could definitely improve the product. It can improve the performance and how the company is also seen by the customer, because at the end, they give you all that feedback in the chat. All this data that you collected is basically feedback from the customer itself.
I think it's definitely, whether it's marketing data or not, I don't know, but it's definitely data valuable to marketing. Yeah, so that for sure. I think that's also when you look at what we did back then in the team. We do not only look at what the customer told us, but we of course connected this with data points across the company, right? So we connected that with interactions with clickstream data from the user going over the website to find out, okay, maybe can we detect if a customer is going to have a problem, for example, in a checkout phase, before they actually call us then, maybe based on some clickstream data and some click pattern, we can already see, okay, the person is struggling with something, and perhaps it's easier to just show him an automated pop-up then that probably fixes his problem or gives him some more instructions instead of the person calling us. So I think when we talk about that data or also marketing data, I think it's always super advantageous if you have the possibility in your company not to have actually these silos about data, but to be able to connect them across the company.
So basically, here we have to talk about the problem, or more or less about the architecture, how data sits within the organization itself, because there are those decentralized models, there's the centralized model, there's the embedded analyst. There are different types of models. In those cases, what would you say has a good advantage? Because at least in your case, you're telling me, you need to have access to different data sources, so you kind of have to own it, or you have a very good collaboration between the different departments.
Yeah, absolutely. So I think my former lead data engineering colleague is probably going to kill me, but I'm, especially when you scale up, right? When you scale up or when you are at a certain scale, managing data centrally, personally, I think is getting hard, very, very difficult to do this centrally. So I would argue that from a certain scale on, or when you expect to scale up quickly, you must look into decentralizing many aspects, how you manage and provide data to your consumers. So for example, thinking back to bol.com, is essentially, right, it's quite a large company, pure tech company essentially. E-commerce is a lot of tech and a lot of logistics. And what was happening there essentially is that team would own their data end to end. So if a team, let's say, deploys a service, any data that is being consumed or produced by this service, imagine a service being, some part in your checkout, in your payment procedure, whatever. That service would process it, but at the same time, it would not only give appropriate responses to other service consuming the service of that service, but it would at the same time also, of course, store that data and provide it in a way that can be used by other teams to analyze it as well. So classic in that case, you're on the GCP. So you would in our case, you would deploy your service in our Kubernetes cluster, and you would at the same time, while bringing timely responses, you would also insert your data into an operational database and have periodic loads into BigQuery, for example. This is then actually BigQuery, right? Our data warehouse in that case is then where other teams would plug into your team's data for analysis and for connecting it to their own data. And essentially, so data is really treated as a product of that team. It's not only the service they deploy, but it's also the data they produce and need to provide to other teams. This is, nowadays you would call it a data mesh, but this is essentially how it was done back then. It has disadvantages as well, because sometimes you do not have the expertise to do proper data modeling in such a team of 6 people whose primary purpose is not producing data and making it nicely available and nicely modeled. So then, of course, you start to get some issues around data not being modeled appropriately. Might be some business logic encoded that nobody actually made transparent. So it gets hard. It can get hard for other users to actually use that data. So there are advantages and disadvantages to this model, but it definitely does scale. But it's not like the golden thing that's going to solve all your problems.
And how about MLOps in this case? Would you say it's a product, or it's a, let's say, team for itself, or is it also something that is part of every team and it needs to be managed separately? Or again, as said before, is it one team?
So maybe to give a bit of context, so currently I'm working for a Transaction Monitoring Netherlands, which is a joint venture of the five big Dutch banks. So ING, ABN, Rabobank, the Volksbank, and Triodos essentially. And what we do, we are essentially a data processor, and we get pseudonymized business transaction data from these 5 big Dutch banks. So that's a lot of data, you can imagine. We process that, try to detect anomalous patterns in that data, in that big transactional graph, and and we try to catch anomalous patterns that might indicate cases of money laundering. My position in that company is I'm the lead MLOps engineer. So obviously I do have strong opinions about MLOps. So MLOps, the way I define it, and it's not a super well-defined field. You can have discussions on LinkedIn over that for 20 posts or more. The way I see MLOps is any process or activity that facilitates model development. So that means any process or activity that makes model development more streamlined, faster, easier, more secure, or ensures higher quality of your model. This is what I see as MLOps. And this is also what I see as the job of MLOps practitioners to do. We build tools, we build products, we build services that enable data science teams. These are our customers. These are our users. That now, the way I put it, sounds like MLOps is a classic platform team. That means we are not really involved in this, value flow through the company. We are not really actively involved in a team building defining a use case, building a prototype, building a production model. It sounds like we are not really involved there, but we basically provide the platform to do this. This is how I see MLOps primarily. It is a platform team that provides these products and services. But I think this is only one way of the picture how to do successful MLOps. It's usually not sufficient to just draw up this platform and say, okay, here you have it, use it. It doesn't work. You need, at least I believe that you need to think about how do you, to establish a strong link between this platform and the people who develop it. You need to establish that link, a strong link to the teams using it. And that's why I believe actually at the same time, embedding machine learning engineers in these data science teams, and then establishing strong links in terms of a craft or a guild, some companies call it, between the MLOps folks and the MLE folks, to basically have it one big happy family in terms of craft and have a lot of knowledge sharing going on. But at the same time, you're not working in the same teams, but you basically have your really engineers in the field working together with data scientists to bring that model from prototype to production on your platform. That gives you extremely valuable insights, feedback from the user, and at the same time you have an ambassador that really coaches and builds out and supports building out these models on your platform.
So let's break things down a little bit. When you say you basically provide the platform for data scientists to bring the modeling part of it alive, does that mean it starts from, let's say, getting the raw data to doing exploratory data analysis to then starting, let's say, model development to model deployment? Is that the whole flow that this platform provides, or what exactly are the tasks or the jobs that I can imagine of?
So it depends a bit on how you slice it, where you have the interfaces when it comes to responsibility in your organization. I would argue, typically, not always, MLOps starts where the work of a data scientist starts. This is where it starts. That can be, in some companies, that means writing some SQL scripts that fetch data from a data warehouse. This can be where your work as a data scientist starts. And that's also where MLOps starts. So that could be that you're writing some tooling, you're providing some tooling that makes interfacing with the data warehouse easier, for example. It could start there. It stretches all the way then over the model development lifecycle. That model development lifecycle, as I mentioned, starts with fetching data, can be in different ways. And it ends with not having a deployed model, but it ends with having a model in operations. And that is a living thing, right? So deploying a model to production is not like, okay, and now I'm done and I can go back to the next model. You can go back to the next model, but you need to probably reserve 10% of your time for actually maintaining and operating that model. It's a living thing. It's a software product. It's going to get worse over time. So this is essentially the spectrum that MLOps should cover. Look at what does your data scientists do? Where does it start? Typically loading some kind of data, exploratory analysis. Then we're talking about experiment tracking tooling. It goes all the way to then streamlined productionization. What patterns are there that data scientists should follow to really have basically this golden path, a very clear, very structured path, how you bring a prototype to production. And it stretches then to really, how is that deployed? How is that monitored? So monitoring, for example, there is some, drift monitoring, classic performance monitoring, for example, response time. Yeah, so I consider this the spectrum. And I think the most important question that you need to ask yourself as MLOps, what does the data science development workflow look like? Where does it start? Where does it end? What activities are there? And how can we support that?
Data science nowadays, again, is not the newest topic anymore because it's been around the block now for, let's say, a few years or almost a decade now. And during that time, a lot of players also have come up that kind of try to automate some of the processes. I mean, there are lots of tools for A/B testing. There are lots of tools that are kind of, let's say, drag and drop, click based machine learning deployment tools. So in what type of a company actually can have a benefit of having their own MLOps team? And what types of companies should maybe go to those already data science products?
I think so. In principle, I think having an MLOps platform team and using a strong tool set, or using maybe even only like a horizontal platform that covers your use case, it's not something it's not an either or. Actually, no matter what platform you get, right? That can be a full horizontal platform. Think, H2O, Data Robot, or what they all call. Or it can be, or you're tailoring your own stack based on different open source tools or different deep vertical tools. Either way, you're going to need somebody who looks at what do we actually need? What do data scientists actually do? How can we streamline their process, implement that platform, train the data science teams to use it, and maintain that platform and build it out continuously. So I do not consider it an either or. Do you need an MLOps platform team if you just buy some vendor solution? You're still going to need somebody taking care of that in one way or another. I think the question is more like, what would the team do then? And what skills would the team need to do what they need to do effectively?
Okay, so let's say you are, early stage startup, and now you know that you have a product that is that is collecting a lot of data. Now you're basically on board and you have to hire the first people. Here's the challenge. Would you hire an analyst first, a data scientist, an engineer, or someone that is more focused on the MLOps process?
So you are a new startup and you want to get started with data science.
Well, let's say you're a startup at the level where you're already, let's say, collecting data. It's not like I just come up with an idea and today I'm a startup, but I got maybe a few years, I have product market fit, and now I collect a lot of data and I think this data has value. So now I need some data people that help me with it.
Yeah. I think that depends a bit on that depends on various things. So I think MLOps, usually at the small scale, usually there is not much reason to think about it very deeply. There is some stuff like experiment tracking, which is useful even for one data scientist, but you do not need even need one MLOps person for having a proper tooling support for that. So I would argue at the kind of beginning, at a small scale, don't worry too much about MLOps. Worry about maybe one or two specific tools that make your life easier. The time to worry about MLOps is usually when you see scale coming. So when you know, okay, we are going to get that Series A, that Series B round, whatever, and we know we are going to hire 20 data scientists. We want to make a push there. This is the point where you should, before hiring these 20 data scientists, you should make sure you have somebody on board who has a vision for MLOps and can build at least a small team. That before you have like 20 people, hitting their Jupyter notebooks, having no idea how to actually get that stuff deployed in a performant way. You do not want that. You want to first, or at least in parallel, roll out the streamlined golden path and then really scale up your stuff. So I think this is usually the sweet spot where you should start thinking about MLOps. Before that, I think as you said, when you have collected some data, you have some data scientists. I think in that case, it depends a bit on how much business buy-in you have. That's always an important question. How is the business convinced that data science can deliver value? If not, if they're not super convinced, usually you will be forced to get some promising use cases, at least to a prototype level first. So in that case, you need a data scientist, a data analyst, someone who at least can, show some value that if we did this properly, this actually really pays off for business, to get business buy-in, and then you can start scaling. If you already have that buy-in, your CEO perhaps is convinced, data science, definitely we need that. Then you probably don't need to worry so much about that. But then I would argue, get your data in order first, always. Your data is your foundation for any data science activity that you do. And, there is this pyramid, I think it's called data science pyramid of needs, hierarchy of needs kind of, which is similar to the Maslow's pyramid of needs, just for a data scientist. And I think it's an oversimplified picture, but there is a lot of truth in it. Back 5 years ago, when many companies made the mistake of hiring super highly skilled data scientists, PhDs, knowing their stuff inside out. But then, of course, they joined the company and the data was just a mess. And, you could not join two tables because stuff didn't match up. Well, you're just burning people with that and you're burning a lot of money of your company. So in that case, do get your data in order first. Collect the right data, make sure it's properly modeled, make sure it's accessible and understandable.
A lot of lessons I can hear from your experience.
Absolutely. I mean, back then, especially in consulting, people often get you for doing these valuable use cases, POC prototypes, some of these going to production. As a data scientist, not only as a consultant, but also as an internal data scientist, the most frustrating thing is, you get this. Somebody tells you about this use case and you're like, yeah, that sounds great. And sounds really promising. And they say, yeah, we have data. And then you actually get that data. I have a look at that data and you're like, yeah, you have data. But honestly, the quality of that data, not really, Data, yeah, you have tons of data, you have terabytes of data. But if you have terabytes of data and that data is just very poor quality, the value of the data, diminishes very quickly.
I think that's again, how you call it. It's again a sentiment of how important it is to collect the right data and really work from the foundation. Because a lot of companies that over time have collected, let's say through Google Analytics, they have tons of web data in their different, let's say, databases there's some legacy data that is being collected for years, but no one has ever looked at it and the way it was collected. And now suddenly they want to jump on this boat. And again, all this was basically built up by software engineers, the whole architecture oftentimes. And now they start getting on the first data analyst that maybe can connect to a SQL database, pull some data, prepare a dashboard, show what we have. And so far, they're still very convinced that there's so much value behind it. But then once you actually try to do more than just analytics, but really model the data to have some predictive value out of it, then I think that's when often the truth comes around the corner and basically hits you in the face. And
absolutely. And that's then, and I would argue, right, this exactly then seeing that and being able to show, okay, you are collecting this data, but it's collected wrong, or you're not collecting super important indicators that you should collect, or you find out your process seems like really shaky. What's happening there? Often, as a data scientist, you're a bit frustrated because, you probably can forget about the fancy model you thought about. To the business, also these insights are often super valuable because they sometimes do not realize things because they have never looked into their data at this detail. So even if your modeling dream has died, it still means the business can actually, push for some nice process improvements. They can improve their data thanks to your insights.
But don't you think it's also a challenge of communication, of internal communication in a company where you have a business stakeholders that basically has this opinion where they think we're collecting good data and this data is useful. And now you have the data scientist that plays with it and that is kind of convinced by the, let's say, the mission or the vision actually that the business stakeholder has. And they say like, oh, that's a cool project, let me get on it. And they fall in love with it. They look at the data, they play around, they think like, okay, let me start off. And at some point, there's this truth coming to the data scientists where they say, hey, my model is not performing that well. And now you have to report it back. Suddenly everything falls down because now you don't achieve this overarching goal that you had before. And kind of people stop working on the project. It kind of falls down instead of using this insight already, which is, for me, it's an insight by itself, knowing that the model hasn't performed well, instead of thinking, why isn't it perform well? What is the data? How does it look like? And really have a good communication between the business side and the data side.
Yeah, I think that's something that we see super frequently in general. I think a key problem is, right, as you said, businesses, this is a nice use case and we have great data. Then as data scientists, you find out data is not that good, as you said. As business, of course, it's never a comfortable conversation you're having. Because as a data scientist, you're like, my model is bad because, looking at that data, your process is so shaky. The data that comes in, that has never been seen in the last 3 years. What's happening there? Business is going to be like, yeah, but you have all this data. Do your magic. So as you said, there is friction, there is communication, there are communication issues and also issues in responsibilities because it's usually often this is torn apart into different departments. The data scientist might sit in the IT part of the company, the business side sits in the other part, and then there is one thing thrown over the wall to the other department, and it's like, it's your problem. No, it's your model is bad, your data is bad. It's like, okay, then let's just leave it. Let's go to the next use case. And as you said, that's sad because fixing that stuff and at the root, at the source of the problem, and then getting that model out, that can be very valuable. But for that, you need super good collaboration and you need to be one team to accomplish that goal. And by having this wall in between teams, in between departments, it often doesn't work out very well, which is also why I'm a deep believer in bringing the people together in a team, can be a temporary team, to fix a problem, to create a solution. I've not seen the other way work well often when it comes to data science, when stuff is like thrown across the wall, whether that's a use case or that's data, or that's a prototype model thrown over to a group of machine learning engineers to implement it in production. That's always friction. It's always not something you want to have if you really want to make the project succeed end to end.
Indeed. I have now so much more questions, especially about business use cases that could be used with data, with machine learning, and the whole process line. And what you just said, even the way different teams can communicate and come together even as a temporary team to solve a specific problem. But again, we're also running out of time. So I want to leave this maybe to another episode if that's possible. But to close everything off, I know that you provide quality content, and I really enjoy your content on LinkedIn. How can people reach out to you?
Thanks a lot for these compliments. Of course, I can always be reached via LinkedIn, obviously. Simon Stiebellehner, tough name, usually. But otherwise, yeah, I think that's the best way to reach out, definitely.
And again, you're so open. You always jump on conversations I've seen on LinkedIn. So people should just bring up their mind with you, challenge you, or ask you, or whatever. I think you're always a fun person to talk when it comes about data.
Yeah, thanks.
Technical side, but also the business side.
Yeah, thanks a lot. I really love the interaction with people, and that's also why I'm producing content on LinkedIn. It's really because I believe it just opens a lot of doors to people. You get to talk to people you have never met before. You jump on a virtual coffee, you have a nice chat. Yeah, and I think that's super valuable.
So true. And especially nowadays, where once before you heard about, like in some article about some, let's say, C-level or someone that is really good at something, and you just read about them. But nowadays you can actually engage them through those platforms. So I really tell everyone, reach out to Simon, follow him for all great content about MLOps data science. Simon, it was a pleasure having you. It was so much fun.
Thanks a lot, Dimitri. It was a pleasure talking to you.
Thank you for joining us on this episode of the Data and Marketing Nation. If you want to put your marketing data to action, head over to vanalize.com. I wish you a wonderful day and see you on the next episode.